Hi, and welcome to the Worldwide Center of Math's Problem of the Week. This week, our problem is find the number of triples ABC of positive integers such that a plus ab plus abc is equal to 11. So to begin, looking at this equation, what we can do is actually factor it. Obviously, there's an a variable term in each of the different parts of the equation, so we can factor out the a. And with the factored version, what we notice is that obviously a, as it stands by itself as a variable, and the term 1 plus b plus bc both have to be factors of 11. And we know that 11 is a prime number, meaning that the only factors of 11 are 1 and 11. So really, the options that we have for what a can equal is 1 or 11. And what you'll notice is that since b and c, by the problem statement, both have to be positive integers, what we can tell from that is that there's no way that a could be equal to 11, and we could find positive integer values for b and c that would make this equation true. So really what that tells us is that a must be equal to 1. So now we can rewrite this equation knowing that a is equal to 1. And rewriting it, it's pretty clear. We can see that the term 1 plus b plus bc must be equal to 11. And we can switch things up a little bit, subtract this 1 over here, and rewrite it. So we know that b plus bc must be equal to 10 when we subtract the 1, and factoring out, we can see that b times 1 plus bc is equal to 10, and kind of following the same procedure that we did from above. Obviously, b and the term 1 plus bc have to be factors of 10, and the options for possible factors. The possible factors are 1, 10, 2, and 5. And based on what we did above, we can do kind of a similar thing to cross out 10 as a possible answer for what b can equal. If b were equal to 10, what we can see is that since c and b both have to be positive integers, there's no number that we could find for c that would make this equation true if b were equal to 10. So right away we know that b can equal 10, but that leaves 3 options for what b could be equal to. We have 1, 2, and 5. Since we now kind of have what a is equal to, possibilities for what b can be equal to, and these are triples, really what we can do is plug them all in and see if they come out with kind of valid variables for what c is equal to. So right away we already know that a is equal to 1 based on the work we've done before. And in the case that b is equal to 1, you'll notice that it all actually ends up working out, and what we can see is that c is actually equal to 9 in this case. And once again, we know that a is equal to 1, but saying that b is equal to 2, once again, everything works out, and what we can see is that c is actually equal to 4 in this case. And once again, we know that a is equal to 1, and saying that b is equal to 5. What we then find is that c is equal to 1. So in total, the number of triples that we have found that really follow the problem statement and are valid for this equation is 3 in total. So that's all we have for you today for this problem of the week. I hope you enjoyed watching it. Please check out some more of our videos on YouTube. Check us out on Facebook and subscribe on Twitter. Thank you.